Okay, number 27 is this bizarre thing called a difference quotient. So I'm supposed to find this fraction. So my function is x, the square root of x plus 4. So f at 2 plus h is going to be the square root of 2 plus 4 plus h, and then minus f at 2. So that's going to be x is 2 plus 4, and yeah, that's the square root of 6, all over h. So I'm going to simplify this. So that's the square root of 6 plus h, or h plus 6, minus the square root of 6, all over h. So I can't cancel the h's directly, so I'm going to multiply by 1 in the form of the irrational conjugate of this divided by itself. So I'm going to do the square root of h plus 6 minus the plus the square root of 6 divided by the square root of h plus 6. Waiting on the little spinning wheel. H plus 6 plus the square root of 6. So once I distribute that out using difference of two perfect squares, I get h plus 6 minus 6, all divided by h times the square root of h plus 6 plus the square root of 6, and the 6's will cancel to 0. Now that I'm here, I can cancel the h's to 1. So my final answer is 1 over the square root of h plus 6 plus the square root of 6, which makes no sense at all to me. But let's go check the answer. So 1 over the square root of, I'd call it h plus 6 plus square root of 6. Same thing. So why in the world would we want to do that? If you just want the answer, you can stop here. But if you've had calculus, so I'm going to get this out of the way. If you've had calculus, you know that the definition of a derivative comes from this limit definition. So if we do the same process here, so the limit, and I like using c instead of h. So the square root of x plus 4 plus c minus the square root of x plus 4, and we put in the c, and then we do the complex conjugate over itself. So the square root of x plus 4 plus c plus the square root of x plus 4, and then square root of x plus 4 plus c plus the square root of x plus 4. And if we do that multiplication, we still got to carry the limit through. Limit of c approaches 0. So this is going to be x plus 4 plus c minus x plus 4 all over c times the square root of x plus 4 plus c plus the square root of x plus 4. So the x cancels, the 4 cancels. I can then cancel the c to a 1. So I end up with the limit as c approaches 0 of 1 over the square root of x plus 4 plus c plus the square root of x plus 4. I can now evaluate this limit because if I let c go to 0, I'm not dividing by 0. So if I let c go to 0, I've got square root of x plus 4 plus the square root of x plus 4, which of course is 1 over 2 times the square root of x plus 4. And again, that's the limit process, so that's the derivative of our original function. F of x equals the square root of x plus 4, so that's the derivative. And if you want to verify this in the calculator, we can do that. Shift minus to get a derivative, put in an x, tab, then square root of x plus 4, 4, so 1 over 2 times the square root of x plus 4. And that concludes this video.